Question number 21. A platform is supported by a spring. A box is placed onto the platform. The diagram shows the spring before and after the box is placed onto it. What is the term for the quantity marked as x? So here from this picture you could clearly see that it's the distance from this point to this point. So it's certainly not the load, which means the force, and strain is the deformation. So here is not the deformation, it's delta x over x value, but here it is just the change in the length, only the delta x, not the actual length. And stress is also representing the pressure. So here this is not the pressure, so the pressure is by the force on the spring. So the correct option is option A, compression. So which means it's squeezing. So spring was before like this, and after the box is placed on it, there is a compression happened, and it is by this distance x. Question number 22. A copper wire has a length 1.7 meter and uniform diameter 0.64 millimeter. The Young's modulus of copper is 1.2 times 10 to the power of 11 pascals. What is the spring constant of the wire? So the Hooke's law is F is equal to Kx, and here it is the extension, and the Young's modulus formula is Y equals to Fl divided by A delta L. F is representing the force, L is the actual length, A is the area of cross section, and delta L is the change in the length or the extension. So the Hooke's law, you can just rearrange it as F is equal to K delta X. You have to include the Hooke's law because you have to find out the spring constant K. So the actual Y formula, the Young's modulus formula, doesn't have K. That's why we are using the Hooke's law. And from this you can write down the spring constant K is equal to F divided by delta L by the Hooke's law. So here we have the F divided by delta L given. So we can substitute that as the spring constant K, L divided by A. So we are using this formula, Y is equal to KL divided by A. So after rearranging into the spring constant as a subject, the formula is YA divided by L. So K is equal to Y is the spring constant value, which is 1.2 times 10 to the power of 11, and area of cross section is basically pi r square since it is a wire, and here what we have is the diameter. So the radius is 0.64 divided by 2, which is 0.32 millimeter, or it will be 0.32 times 10 to the power of -3 meters. So we can substitute that, which is pi times 0.32 times 10 to the power of -3 whole square divided by the original length, which is 1.7. So after substituting these values, it is 22,708.70 Newton per meter, which is in the standard form 2.3 times 10 to the power of 4 Newton per meter. So the correct option is option A. Question number 23. The graph shows how the extension of a spring varies with the force used to stretch it. So this is the graph. What is the elastic potential energy of the spring when the extension is 4 centimeter? So when there is a spring, the actual length is getting changed by the extension. So at this point, when the extension is 0, the spring is at the actual position. Then as the force has exerted, there is an extension, and here it is given up to 4 centimeters. So for that extension, the force applied is 30 kilonewton. So for the 4 centimeter extension, it is 30 kilonewton, and the extension is 4 centimeter. So we can use the formula for the elastic potential energy, which is the energy stored in a body when it is stretched or compressed. So here the X is representing the extension and K is the spring constant. And you have the potential formula by the spring constant and the extension alone. You can directly use this by finding the K value and substituting, or otherwise we can have another formula, another rearrangement for the formula by just splitting the extension as x dot x. So here kx is representing the force, so half fx is another formula. So we can just substitute for the force, which is 30 times 10 to the power of 3 multiplied by 4 centimeter, which is 10 to the power of negative 2. So after substituting, you will be getting the values as 600 joules. So the correct option is option C. Question number 24. Which road describes a progressive longitudinal wave? So first one is transfers energy in a direction parallel to the oscillation. So since it is longitudinal wave, it is parallel, so it is true. Requires a medium to travel through. Yes, it requires a medium for the longitudinal waves and always travels at the same speed. It's not necessary to be the same speed. So it will be a false statement, and the correct option is option D. Question number 25. What is the phase difference between points P and Q on the progressive wave shown in the diagram? So here is the P point and here is the Q point. And you could see in between the 2 points there is a complete wave travel. Like here is the crest position. The next crest is over here. So the degree is 360 degree, and after that it has covered 1/4 of the 360, so which will be 90. So 360 plus 90, which is 450. So you can find out like this, or otherwise you can go for a formula. So between the two waves, as you know, it is the 1 whole lambda and 1/4 of lambda is taken, or otherwise you can just find out. Anyways, it will be of the same value. The extra one is about the lambda by 4. So you can convert this lambda by 4 into the degrees. This is the path difference. So path difference between the 2 points is lambda by 4. So the phase difference will be having a formula that phase difference equal to 2 pi over lambda multiplied by the path difference. If the values is in like in radians, or otherwise you can go for the formula 360 divided by lambda multiplied by the path difference. Since you need the values in the degrees, you can go for the second one. So 360 divided by lambda multiplied by lambda by 4, the path difference. So lambda get cancelled, so 360 by 4, which is 90 degree. So either you can go for these formulas, or you can just directly find out like this. Question number 26. The graph shows the variation of displacement with distance for two progressive waves x and y of the same type in the same medium. So here is the displacement and the distance given. So from this one you can find out the value and the amplitude from this graph. The intensity of the wave x is I. What is the intensity of the second wave, which is y? So here for the intensity, it is always proportional to the amplitude square. So for the first wave Ix is proportional to ax square. Same for the second wave y. So Iy is proportional to ay square. And if you are taking the ratio, it will be Ix divided by Iy is equal to ax square divided by ay square, or you can take it as ax divided by ay whole square. So what you need is the intensity of the second wave, which is Iy. So Ix is given as I. So considering the formula, it will be I divided by Iy is equal to Ax is the value from this point to the maximum. So maximum displacement is the amplitude. So the maximum point is here, which is 0.4. And for the y, it is this point, which is 0.67, and it's 0.75. So substituting these values, so and these values is in centimeter. So since it is in the ratio, we don't have to worry about it. So here you can substitute for Ax as 0.4 divided by Ay, which is 0.75 whole square. And after finding this, this value will be equal to 0.284. So for Iy, it will be I divided by 0.284, and that is equal to 3.5 I. So the correct option is option D. So you can go for this formula, or otherwise you can just rearrange this formula. Just divide in the opposite way. So you will be getting Iy divided by Ix, which is equal to Ay divided by Ax and whole square. So you just need to cross multiply this Ix to the right side. So you can directly go for this, or otherwise just divide the ratio value. Both will be giving you the correct answer. Question number 27. A moving source emits a sound of frequency 1200 Hz. A stationary observer hears the sound of frequency 960 Hz. The speed of the sound is 340 meter per second. What could be the velocity of the source? So here you could see it was emitting a higher frequency, and what the stationary observer hears is a lower frequency. Since the frequency is decreasing, we could confirm that the moving source is moving away from the observer. That's why lower the frequency and higher the wavelength. So you can consider the option A and option C. And what about the velocity value? So for that you can use the formula of Doppler effect. So the formula is F dash is equal to F multiplied by, so the substituting the moving source actual frequency, and the V is 340 velocity of the sound, divided by 340 plus the velocity of the source, which is like you don't know. So here the value F dash is 960. So after doing the rearrangement, you will be getting it as, you can do it like this, 960 divided by 1200 and 340 divided by 340 plus x. And when you're cross multiplying, you will be getting 0.8 340 plus x is equal to 340. And again you can divide the value with 0.8. You can move the 0.8 to the other side and minus this 340, and that value after calculation it will be 85 meter per second. So the correct option is option C. Question number 28. A light wave passes through a single slit and a diffraction pattern forms. What happens to the frequency and the speed of the wave when it is diffracted? So when there is a diffraction happens, it's simply the bending or spreading of the waves when they pass through a slit or around an obstacle. So the diffraction will not be altering the frequency, because frequency is just depending upon the source. So we are not changing the source at all. So frequency remains the same. So no change. And for the speed, it is a constant value for a particular medium. So it's given that the light source is moving in this particular medium, and the diffraction is not gonna change it. So what will be changing is just the direction and the intensity distribution of the wave. So the speed is also not changing. So option D is the correct answer. Question number 29. The equation n lambda is equal to d sine theta can be used with a diffraction grating to find the wavelength of visible light. Which quantity is not correct for use in this equation? So which is not correct? So the formula is the grating formula, and D is representing the grating spacing. Theta is the angle of diffraction for the nth order maximum, and n is the order of the diffraction maximum, and lambda is the wavelength. So here D is representing the distance from grating to the screen. It is actually represented by capital D, not a small d. So the correct option is option A. Question number 30. Two progressive sound waves move in opposite directions and superpose to form a stationary wave. Which statement describes an antinode of the stationary wave? So antinode is the maximum amplitude. So the first options A and B are representing the positions where the phase difference between the two waves is always 0 degree and always 180 degree. The amplitude has nothing to do with the phase difference. So it will be either C or D the correct option. So here the maximum amplitude will call it as antinode, and the position where the stationary wave has the minimum amplitude is the node. So the correct option is option C. Question number 31. A student connects two loudspeakers to a signal generator. As the student walks from P to Q, he notices that the loudness of the sound rises and falls repeatedly. What causes the loudness of the sound to vary? So here it is the intensity increase or decrease, and it's not about the diffraction because diffraction is through a slit or around an obstacle. Here there is no obstacle, and Doppler effect is when the source is moving. The source is not at all moving. The speakers are constant or fixed at a point. Interference is the correct option, and if you are checking the option D, it is the reflection. So here there is no medium to reflect. It is interference because the source is like there is a source from the one of the speaker, and the other one is also producing a source. So these two are connected to the same signal generator, which means that these two waves are coherent, and they will do a superimposition to form the high amplitude and the low amplitude, or the high intensity or the low intensity will get constructive and destructive interference. That's why the student notices that the sound rises and falls repeatedly. Question number 32. The current in a resistor of constant resistance is 8 milliamperes. The power dissipated by the resistor is P. The current in the resistor is increased to 12 milliamperes. What is the new power dissipated by the resistor? So here what you have is the power value, and the formula is IV. But the voltage we are not sure about, but it's given that the resistance is constant, so we have to have a formula with the resistance. That's why we are substituting this V in terms of Ohm's law as IR. So I multiplied by IR will give you I square R. So if you are considering the previous condition, the power is P, and that is equal to I square R, so which is 8 square multiplied by the R, and the new one, as the current has increased, it will be 12 square R, and you can divide these values. So P dash divided by P is equal to 8 square R divided by 12 square R divided by 8 square R. R and R get cancelled. So 12 divided by 8 all square is P dash over P. So if you need to find out the P dash, it is this ratio multiplied by P, and the ratio is 2.25 P, or it's nearly 2.3 P. So in terms of the Ohm's power value, it is 2.3 P. So the correct option is option D. Question number 33. A piece of wire X has a resistivity rho, length L, and cross-sectional area A. Wire X has a resistance R. A second piece of wire Y is made of a different metal. It has the same resistance as X but has twice the length of X. Which row gives possible values for the resistivity and the cross-sectional area of Y? So here it is given that the second piece of wire Y is made of different metal. So the resistivity is a property of the metal. It's not the same metal, which means that the resistivity will be different. So the option C is not correct because the resistivity is the same here. So it will be A, B or D, any of it. So the resistance R is equal to rho L divided by A. This is the general formula, and it is given that the wire Y has the same resistance as that of X, which means that Rx is equal to Ry. So substituting the conditions, the equations for Rx and Ry. For Rx, it is rho L divided by A. But for Ry, it is a different rho value, so we can consider it as rho dash, and the length is twice the length of the L, so it will be 2L divided by A, we don't know. So here using this, you can just rearrange this one, like you can cancel the L value because it's double, and it follows the formula rho divided by A is equal to rho dash divided by 2 rho dash divided by A. So we can substitute those values, those options. So if you're substituting for the rho dash as half rho, is it equal to rho by A or not? That's how we are going to find out the correct option. So once you are substituting the first one, it will give you 2 multiplied by rho dash, we can give it as rho by 2, divided by the area is A by 2, so 2 and 2 get cancelled. It will give you 2 rho by A. So this is not the correct option. Then option B, after substituting 2 rho by 2 divided by A. So 2 and 2 get cancelled. It's giving you the actual value. So the correct option is option B. Question number 34. A cell of electromotive force EMF E delivers a charge Q to an external circuit. Which statement is correct? So here it is the EMF value. So EMF is the work done by the cell or the energy supplied, and this is the formula. So here the first option is the energy dissipated in the external circuit EQ. This is not a correct option because the external circuit will be having only a part. So the energy is then dissipated partially in the external circuit and partially inside the cell. So EQ is not a correct option because E is the total EMF. And option B, the energy dissipated within the cell is EQ. So not all the E value is dissipated inside the cell, so this is also wrong. Then option C, the external resistance is EQ, definitely not. This is also wrong. The resistance value is not the potential multiplied by the charge, it is the work done. Then option D is the total energy dissipated in the cell and external circuit is EQ. This is correct because partially inside the cell and the remaining is on the external circuit. So correct option is option D. Question number 35. The diagram shows a circuit with a battery of EMF 60 volt and negligible internal resistance, a 20 kilo ohms resistor, a thermistor and a voltmeter. The resistance of the thermistor is 20 kilo ohms. The temperature of the thermistor decreases, and this causes the resistance to change by 50%. After this change, what is the reading on the voltmeter? So if the thermistor used is a NTC, negative temperature coefficient type, then as the temperature has decreased, the resistance must increase. So initially it is 20 kilo ohms, the fixed one, and the thermistor also has 20 kilo ohms. So if it is changes by 50%, so if it is an increase, it will be the 50% of 20, which is 10 kilo ohms, has increased. So the new resistance will be 30 kilo ohms. So you can either use this potential divider formula. So the potential divider formula will give you the correct, like the direct answer. So that formula is V is equal to R divided by R total multiplied by the total voltage. So we can substitute. So you need to find out across the fixed resistor. So the 20 kilo ohms divided by the total resistance. So these two resistors are connected in series. So the total resistance is always adding up of the two resistance value. So 20 plus 30 will be 50 kilo ohms here, multiplied by the voltage which is 60 voltage. So 20 divided by 50 multiplied by 60, which is 24 voltage. You can directly get this. Otherwise you can find out for the current value and then the voltage value. So to find out the current, you can use V divided by R formula, which is 60 divided by the total resistance, which is 50, and the voltage formula is IR, which is 60 divided by 50. The resistance across the voltmeter is 20. So if you are doing this one, is also actually the same. This is also giving you the same answer. So the correct option is option B for this question. Question number 36. A potentiometer circuit is used to determine the electromotive force Ex of a cell. The circuit includes a second cell of non-EMF E0 and negligible internal resistance and a uniform resistance via PQ of non-length. Ex is less than E0. Then the movable connection J can be positioned anywhere along the length of the resistance of wire. Which circuit is suitable for determining Ex? So in a potentiometer setup, a non-cell of EMF E0 is used to establish a uniform potential gradient along the wire PQ. That's one of the conditions, so that you will get a uniform potential gradient. Suppose you are connecting 5 voltage. At the positive end it will be of the 5 voltage, the high potential. On the negative end it will be of a 0 voltage. So along the length of PQ there is a decrease. So at this point it may be 4, it may be 3, 2, 1, such that there is a potential gradient. So how we can check each of the option. Option A is connected correctly, but here in the option B, Ex, the unknown one, is connected, so it's definitely not. And if you're checking EC, it is also connecting the non one. The ED, this is also connecting the non one, so it's definitely not B. Then the another one is an unknown cell of EMS is connected with the galvanometer and a sliding contact to find the null point. So as you are moving the movable connection, at which voltage it is equal to that Ex value, you will get a null point on the galvanometer. That's why. So the galvanometer should be connected along with the unknown voltage. So here it is connected correctly, but here you could see it is connected with the non one, so option C is wrong, and here also it's connected correctly. Then the next one is the potential value, the connection of the EMF. So here E0 is giving the positive to this end, but here it is connected to the negative. That's why this one is wrong. and all of the options is wrong except D. So for the D, the positive is connected on this point, and here also the positive is connected over here, and the negative is connected to the same point. So negative to negative, positive to positive. So the correct option is option D. Question number 37. The principles of conservation of which two quantities are associated with Kirchhoff's first and second laws? Kirchhoff's first law is the current law, which means that the current at a junction is equal to 0. So it means that the charges are conserved. So the first law means that the charges are conserved, because current is basically how many charges is passing per the time. So if the current is joining at a point or splitting at a point, basically the charge is what making the changes. The second law is about the voltage. So the voltage is meaning the conservation of energy, because voltage is the energy per the charge. How much is the energy given per charge? So it is energy. Correct option is option A. Question number 38. An up quark in a hadron changes to a down quark. The elementary charge is E. What is the magnitude of the change in the charge of the hadron? So quark is a fundamental particle that combines to form proton and neutron. So basically there will be two quarks combined. So here the types of the quarks, or we will call it as a flavors, are up, down, strange, charm, top, bottom. So for the up type it will be 2 by 3e. For the down type it will be negative 1 by 3e. So the protons is having like proton and neutron. Those are having at least the proton and neutrons are having the three flavors of quarks. So suppose it's given that the up quark is changing into a down quark. So what will be the change in the charge? So you could see the down quark is negative 1 over 3e, and the difference is what you need to find out. So negative. Then for the up quark it is plus 2 by 3e. So after doing the substitution, so it was negative 1 minus 2 divided by 3. If you are taking e common, which is negative 3 divided by 3e, that is negative e. This is the change. So what you need is the magnitude of it. So magnitude of the change in the charge is E. So the correct option is option C. Question number 39. A nucleus of magnesium 23 decays to form a nucleus of sodium 23, emitting a beta plus particle and a particle X. What is particle X? So this is how the magnesium changing into a sodium by emitting a beta plus, which is a positron. Along with that you will be getting a neutrino. So the correct option is option D. Question number 40. A nucleus of uranium-238 decays in stages by emitting alpha particles and beta minus particles, eventually forming a nucleus of 206 lead. How many alpha particles and how many beta minus particles are emitted during the decay chain? So by the alpha particles, if the element is having a proton number of Z and the mass number is A, we can represent the element as X. Always the proton number will be decreasing by 2 and the mass number will be decreasing by 4 after emitting the alpha. If it is for a beta particle, there is an increase in the proton number, and so it will be of a different element. So let's represent it by Y, but the mass number stays the same. This is how the changes are. So we can find out how many alpha particles are emitted first. So since there is a change in the mass from 208 uranium 92 to 206 lead 82, the change in the mass number, which is 238 minus 206, that is equal to 32. So since each of the alpha particle is decreasing by 4, we can find out the number of alpha particles by just dividing 32 by 4, and that is equal to 8. So there is 8 alpha particles emitted. So you could see that as the 8 alpha particles are emitting, the proton number is also decreases by 2. So 8 multiplied by 2, which means that 16 is the decrease. So 92 minus 16, and that is 76 should be the atomic number. But here you could see it is 82. So since the each of the beta minus emission, there is an increase in the alpha part, the proton number by 1. We need like 6 more. 82 minus 76 is basically 6 beta particles should be added. So 6 is the beta particles emission. So the correct option is option A.